Figure shows aluminum wire of length 60 cm joined to a steel wire of length 80 cm and stretched between the two supports. The tension produces 40 Newton. The cross-sectional area of the steel wire and aluminum wire is 1 mm square and 3 mm square respectively. What could be the minimum frequency of the tuning fork which can produce standing wave in the system with the joint as a node? The density of aluminum is 2.6 gram per centimeter cube and that of steel is 7.8 gram per centimeter cube. Right. Now first of all, I'll calculate the mass per unit length for steel as well as aluminum. Now mass per unit length can be written as density of steel into cross-sectional area of steel. Fine. So density of steel is given as 7.8 and it is gram per centimeter cube. Area of cross section is given as 1 mm square, that can be written as 10 to the power minus 2 centimeter square. So it comes out to be 7.8 into 10 to the power minus 2 gram per centimeter. Fine. Similarly for aluminium, it will be rho of aluminium into area of cross section of aluminium. So it is 2.6 into 3. So it also comes out to be 7.8 into 10 to the minus 2 gram per centimeter. Now it is given clearly visible that mass per unit length of steel is equal to that of aluminium. So the wave speed will be given by under root of T by mu. Now in steel as well as in aluminium, T is same, mass per unit length, that is mass density, is also same. So the wave speed of steel as well as aluminium will be the same, and that comes out to be tension is 40 divided by 7.8 into 10 to the power minus 2 into 10 to the power minus 3 divided by 10 to the power minus 2. That will make it into kg per meter. So it gets cancelled. Wave velocity comes out to be 500 by 7 meter per second. Fine. Now this is the velocity. What I want is that the node, I mean this point, the junction has to be in the node. So it should be something like this. Fine. So what I want is that if the width of the loop is x, then this total length, that is x times of some loops, should be equal to 80 centimeter and x times of some loop should be equal to 60 centimeter. Or what I'm trying to say is that this x should perfectly divide 80 as well as 60. Right. Now we want the minimum frequency, that means the maximum wavelength, and maximum wavelength, that means minimum loops. Fine. So the minimum loops, for the minimum loops, x should be maximum, and the maximum value of x that can perfectly divide 80 centimeter and 60 centimeter is 20. So x comes out to be the 20 centimeter. Lambda will be equal to 2 times of x, that is 40 centimeter. Wave velocity I know, that is 500 by 7 meter per second. So I can calculate the frequency, that comes out to be v by lambda. So just substitute the value, you get the value of frequency as 180 Hertz. That is answer.